Hi, and welcome to the third and final mini lesson on the periodic table. In this lesson, we hope to answer the question, how do the different families react? Again, once you finish this mini lesson, please feel free to try out the worksheet. If you remember on the last mini lesson, we were talking about the different groups or columns of the periodic table. Now we're going to be looking at their chemical characteristics, and we're going to be giving these columns a family name. So in key concepts to remember, as a quick review from last mini lesson, the elements in the same group or column of the periodic table have the same number of valence electrons. We're going to add to that because they have the same number of valence electrons, they will share similar chemical characteristic properties, and this is what we're going to call a family. We're going to be looking at 4 distinct families in the periodic table: the alkali metals, the alkaline earth metals, the halogens, and the noble or inert gases. The first family we're going to look at is the alkali metals. They're located in the first column of the periodic table. Please note, if you take a look at what is actually highlighted in blue, that hydrogen is not part of the alkali metals, although it is located in the first column. If you think about it, hydrogen is a non-metal, so therefore it does not actually have a family. We just put it there because it does have one valence electron, but it does not react the same way and therefore is not part of the alkali metal family. So let's just quickly take a look more in depth at the alkali metals. Different elements, we have lithium, sodium, potassium, rubidium, cesium, and francium. Obviously, the further we go down this list, the larger the element will get and the more reactive it will become. Certain characteristics for the alkali metals, obviously they're in the first column or group 1A of the periodic table, except for hydrogen, and therefore they will have one valence electron. They are usually soft and highly reactive, and they're so reactive, especially to water, that we're going to have to store them in oil. And because of their high reactivity, we'll never be able to find them in nature. So we'll never find them in their elemental state. So you can't go walking in the forest and all of a sudden find a giant chunk of sodium. It doesn't really work that way. Sodium will always have to be in combination with other elements or in a compound or molecule. So to show the high reactivity of the alkali metals, the next slide actually has a video showing what happens when you put potassium into water, and just to see the actual reactivity. So here we have basically the tongs. It is a Wikipedia video. So we have the tongs holding a piece of potassium, and we're going to take a look at what happens when they drop it in the water. So we do have a very instant reaction. Probably you've done this with your teacher in class, potentially with potassium or another of the lesser elements. You probably will not have done that with cesium. It's a bit too reactive, and francium, is radioactive, so definitely not with that one. We're going to look at the second group of the second family, I should say, of the periodic table, the alkaline earth metals, which is in the second group or the second column of the periodic table. These will include beryllium, magnesium, calcium, strontium, barium, and radium. Some of the characteristics, they're second column, so group 2A. Therefore 2 valence electrons. They do form compounds in rocks, which is why we give them that name, alkaline earth metals. They are still reactive, not as much as the alkali, but they are still highly reactive, and they are highly malleable. We can bend them very easily. And it is because of their high reactivity that we'll never be able to find them in their elemental state in nature, the same way we were not able to find alkali metals in nature. This here is just a video to show how reactive alkaline earth metals actually are to heat. So in this case, we have a piece of calcium and we are going to heat it up, and you're going to see a very bright light formed. If you've ever done this in class, your teacher probably did it with a strip of magnesium. It is very important if you ever see this live not to look directly at the light, as it can be very damaging for your eyes. So we can see the reaction right here that an alkaline earth metal will actually have with heat. We're moving on to the third family that we're going to look at in the periodic table, the halogens. And this is all the way on the other side of your periodic table. It's the before last column. So this includes elements such as fluorine, chlorine, and so on and so forth, all the way down to unseptium, which might have a better name at this stage of the game. If you look closely though, please note right under that blue highlighted zone, you're going to realize you have two elements, elements 71 and 103. They are not part of the halogen family because they're not actually in the before last column. Those two bottom rows are supposed to fit into the periodic table and stretch it out. But because it makes it less attractive and not as compact, we actually just remove them from the periodic table and place them down below. So they're not actually part of the halogens, although they do line up with that seventh or before last column, I should say. So some characteristics of halogens, obviously before last column. So they have are found in group 7A with 7 valence electrons. They do react easily, often to form salts. So for example, table salt is sodium chloride. You can also have magnesium chloride and other salts which are not necessarily edible. And halogens are often used as cleaners or as disinfectants. Noble gases, or the final family that we're going to be looking at, also known as inert gases, are located in the last column of the periodic table. These will include all of the following elements here, so helium, neon, argon, krypton, xenon, radon, and an octium. And their characteristics, basically they're found in the last column of the periodic table. They have 8 valence electrons with the exception of helium. Because helium only has 2 electrons, it will only have 2 valence electrons. And what makes noble gases so special is they do not react. They are stable. So you will never find them in a compound or in a molecule or something else. They will be found as is in nature. They're found in their elemental state. So to quickly review, elements in the same group have the same number of valence electrons. Because they have the same valence electrons, they will react in similar fashion in certain conditions. That is what we'll call a family. We look at 4 families in the periodic table: the alkali metals, alkaline earth metals, halogens, and noble gases. When comparing the alkali metals and the alkaline earth metals, we realize that the alkali are in the first column, except for hydrogen. Alkaline earth are in the second column. Alkali metals have 1 valence electron, while the alkaline earth have 2. One is soft and highly reactive. The alkaline earth are the ones that form compounds in rocks. Alkali metals, because of their high reactivity, especially with water, are stored in oil. Alkaline earth metals are still highly reactive, but they don't have to be stored in oil, and they're highly malleable. They can be bent easily. They do share one thing in common: they're never found in their elemental state in nature. When comparing halogens and noble gases, halogen is in the before last column of the periodic table, noble gas is in the last. Halogens have 7 valence electrons, noble gases have 8, except helium that only has 2. Halogens react easily, often form salts, and are used as cleaners or disinfectants, whereas noble gases simply do not react. They are found as is in nature.